Hello everyone and welcome to Geometry Section 4.5, the converse of the Pythagorean Theorem. In our last lesson, we learned the Pythagorean Theorem. Since we know that, and we know what a converse is, it shouldn't be too tough for us to hypothesize about this converse. The Pythagorean Theorem starts off with a right triangle, and then gives a relationship that must be true for all right triangles. In the converse, we're going to be given three sides, and then use their relationship to determine whether or not the triangle has a right angle. This theorem is really useful in helping to classify triangles by their angles, and it's also important in that it lets us determine angle measures from side lengths. So what is this awesome beast, you ask? It's the converse of the Pythagorean theorem. It says that if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. In other words, if a squared plus b squared equals c squared, then it's a right triangle. If it is a right triangle, we'd also be able to figure out which is the right angle, since it will be opposite the largest side, or the hypotenuse. Let's give this theorem some exercise. In our first example, we have a triangle with side lengths 9, 12, and 15. The longest side is 15, so that will have to be on the side by itself. Then we write our equation: 9 squared plus 12 squared equals 15 squared. 9 squared is 81. 12 squared is 144, and 15 squared is 225. Adding 81 and 144 does give me 225, so I know this is a right triangle. Let's try another example. In this problem, the triangle has sides of lengths 2, 2, and 4. 4 would have to be the hypotenuse, so it goes off by itself. Our equation will be 2 squared plus 2 squared equals 4 squared. 2 squared is 4, and 4 squared is 16, so we have 4 plus 4 equals 16. 8 does not equal 16, so this is not a right triangle. Bummer, right? But wait, it isn't a total loss. We can still use this information to classify the triangle. We just need a few extra guidelines. In our example, the sum of the squares of the side lengths was less than the longest side squared. What kind of triangle is formed when I lengthen the hypotenuse? Hopefully, you recognize that as an obtuse triangle. When I make the square of the hypotenuse smaller than the sum of the squares of the other two sides, then what happens to the triangle? Three acute angles form an acute triangle. So now we can go further than just, yes, it's a right triangle, or no, it isn't. We can actually classify the triangle by its angles. When you're writing your problems out, I'd suggest leaving a little bubble between the square of the longest side and the sum of the squares of the other two. That way, once you've evaluated each side, you can fill in the blank and make your decision. Just a suggestion. So if the square of the longest side is less than the sum of the other two squares, it's acute. If the square of the longest side equals the sum of the other two squares, it's right. And if the square of the longest side is greater than the sum of the other two squares, it's obtuse. Ready to give it a shot? Let's go. So our first triangle has sides 7, 9, and 11. 11 is the largest, so that will be C. We need to see how 11 squared compares to the sum of 7 squared and 9 squared. 11 squared is 121, 7 squared is 49, and 9 squared is 81. 49 plus 81 is 130. That's greater than 121, so this triangle is acute. 30, 24, and 10 are next. 30 is the longest side, so that's C. How does 30 squared compare to 24 squared plus 10 squared? 30 squared is 900, 24 squared is 576, and 10 squared is 100. 100 plus 576 is 676, which is less than 900, so this triangle is obtuse. One last example for this lesson. 12, 37, and 35 are our side lengths. 37 is the longest side, so that has to be C. Then we need to see how 37 squared compares to 12 squared plus 35 squared. 37 squared is 1,369. 12 squared is 144, and 35 squared is 1,225. 144 plus 1225 is 1369. That means the two sides are equal, so this is a right triangle. You might want to add those three to your list of Pythagorean triples, if you're keeping one. Nice work on this lesson. Remember, you can rewatch any parts of this video if there was something you didn't understand or something you'd like to look at again. Thanks for watching, and happy hypothesizing.